In this example, we're once again looking at the area between two curves. This one, however, appears as though the functions are a little bit larger in power, meaning, again, stronger polynomials, which could cause us to have a little bit more difficulty, A, graphing them, and B, working with their integrals. So the first thing I'm going to do is, again, I'm going to work on graphing those functions. So f of x equals to 3x cubed minus x squared minus 10x. Now, if I remember how to graph a cubic, I know cubics mostly look like this to some form or another. But I need to be very careful to make sure that I graph it accurately so I know where my functions are going to intersect and how they're going to appear. So the first thing I'm going to do is I'm going to go ahead and approach graphing this function in a way that I learned in pre-calculus by factoring and finding the zeros. So if I go ahead and attempt to factor this, remember that I'm going to go ahead and do 3 times the negative 10, giving me negative 30. I need two numbers that multiply to get me negative 30, but add to get me a negative 1. You'll recall that those two numbers are negative 5 and positive 6. So that means that those are the two numbers that this thing should factor into. Now, if you've forgotten how to factor this, again, I'm going to show it very quickly in here, so that I have 3x squared minus 6x plus 5x, and then minus 10. And then I'm going to use grouping by factoring out 3x, giving me x minus 2, and factoring out a 5, giving me x minus 2. Again, if these two things aren't the same, then this doesn't factor appropriately, and I'm left with x minus 2, and 3x plus 5. So now by factoring this, again, this is only necessary for us to know what this graph is going to appear like. So I know that I'm going to have zeros of x equals 0, of x equals 2, and of x equals to negative 5 over 3, which is approximately 1 and some change. Now, given this information, I can actually graph this function relatively accurately. I also know that because this is a positive cubic, it's going to look like this and not like this. So, I'm going to go ahead and plot 0. I'm going to plot 2. I'm going to plot approximately negative 1.6. And then I'm going to go ahead and sketch this graph so it does something like this. And I'm going to exaggerate those details because I want to make sure that if this thing does do anything crazy in regards to this quadratic, that I capture that. So the next piece I've got to deal with is this thing right here, this g of x. Now again, notice how all this work was algebra to start. Now my g of x function is equal to negative x squared plus 2x. Again, I know, number one, that it's a quadratic facing down. It's going to look something like this. And then I'm going to go ahead and figure out where some of the details are. Now, I can't find the vertex on this one because of the way that it's been graphed. However, I can very easily identify that I have x factoring out and left with negative x plus 2, giving me x equals 0 as being one of the x-intercepts. And then this solving this one, giving me x equals to 2, being the other one. So it looks like I've got those 2 points right there as my x-intercepts, and I know that this graph faces down. So this being f of x, my g of x would probably look something like this. And I'm going to go ahead and exaggerate how it looks to make sure it's clear. So it looks something like that. So right there is my g of x. So now you'll notice that there are 3 different locations where these two graphs intersect. There's also, you'll notice, a section here where the quadratic is on top and the cubic is on the bottom. And there's a section here where the cubic is on top and the quadratic is on the bottom. Now, given this, because there's 2 actual regions that are connected by these 2 functions, and this simply said find the area enclosed, that means that I've got to find area 1 here, and I've got to find area 2 here. And if you recall, when I have 2 different areas, that is going to require that I have 2 different integrals. The integral for area 1 is going to be x equals, now I don't know what that intersection point is yet, but I do know this one is x equals 0. So I'm going to go from a negative number to 0, such that my, again, cubic function is on top. My cubic function then being 3x cubed minus x squared minus 10x, minus the bottom function, because again, remember, this is always the top function minus the bottom function in one of these integrals to find the area in this space. If you flip these two, you'll actually end up with a negative area, and that will correlate everything incorrectly. So then I'm going to subtract from that the area, again, under the curve of this g of x function. This g of x function being the negative x squared plus 2x. There's my first integral, assuming I can figure out what that last intersection point is. The area number 2 is going to be equal to the integral from x equals 0 to 1, because, sorry, not 1, 2, because this is 0 and this is 2, so I have this space right here, and the quadratic function now is going to be on top, so negative x squared plus 2x, and I'm going to subtract from that the cubic function, 3x cubed minus x squared minus 10x dx. So these are the two integrals that I'm going to have to figure out, again remembering that this one here is a 2, and then I'm going to have to go ahead and evaluate this integral here after I figure out the algebra of setting those two functions equal to each other and solving for that last missing piece. So this what I'm going to do right now is down here I'm going to go ahead and set f of x equal to g of x. Now I know again there's a lot of algebra in these problems, but it is required for us to be able to figure out how to solve these equations. So this is the set of equations that I'm going to have to solve. I'm going to go ahead and add the x squared to both sides, giving me 3x cubed. I'm going to subtract the 2x minus 12x. So you'll notice here that it is actually relatively simple to hopefully factor 3x out of this, giving me x squared minus 4 equaling to 0, giving me x equals 2 and x equals negative 2 when I factor that finally. Don't forget this equals x equals 0, but since I didn't need that one, I just needed to figure out what this negative case was. So you'll notice that I have intersection points at the x value of negative 2, the x value is at 0, and the x value of 2. So I'm going to start from negative 2 going to 0, and I'm going to have the top minus the bottom, and then I'm going to have a second integral from 0 to 2 of the top minus the bottom. And the reason why, again, I need two separate integrals to do this problem is because the top and bottom function changes over that space. There's no nice way to do this so that I only use one integral, and there's no nice way to do this such that it's simple. We have to simply take these two areas and then we're going to have to add them up. So in terms of integrating these, again, you should be able to do this. I will simply set them up and then I will leave them for you to finish. I'll distribute this negative and I'll combine like terms, giving me 3x cubed, negative x squared plus x squared is no x squareds, and then negative 10x minus 2x is negative 12x dx. So this one should be easy for you to evaluate, again, a1. And then a2 should also be relatively straightforward, going from x equals 0 to 2, where I negate the x cubed, so I'm going to have negative 3x cubed. I'll distribute the negative to this x squared, canceling this x squared out. And then I'll distribute the negative to the 10x, making it a positive 10x, giving me a plus 12x dx. You'll notice something about these two cases. This one here is 3x cubed minus 12x, and this one here is negative 3x cubed plus 12x. They are negatives of each other, and then there is something to say about the fact that these two functions are the exact same function where I've swapped them and technically negated them. So those two areas, once you've evaluated those integrals and you've added them up, will be the answer to this problem.